Hello everyone, welcome. Today, I want to continue Python and Pandas for data science productivity. We are starting about data structures. So the first one that is going to go into it is what's called the list. Okay, and there are other data structures. We'll see them. We'll see lists, dictionaries, sets, strings are most common and also most common. But let's start today with the list. As usual, we are going to use this kind of references, and I'm asking for what is Python version 3.9.7. Yesterday I did that. Last time I slightly passed a complicated looking expression. Okay, this is what is called this complicated expression. Okay, and then I bounded it between two square brackets. Okay, and those are all I called it as positive int squared, integer squared. So I square. This is I star star 2 means I square for I in range 1 to 10, 100,000. Of course, this range is going to range from 1, which means 1 to 100,000 means take all the values from 1, 2, 3, 4, 5, 6 up to 99,999. This this computation is happening within a square bracket. Okay, and what is the specialty about the square bracket? That's what I'm going to talk about today. And it is a container to keep collection of items with specific index attached to each of the item, or specific position attached to each of the item in that container. Okay, that is called a list. So in fact, we did this one. Let's run this one. So I run this one. I get this positive into squared, not 100,000, but only for 10 values I'm doing it, and then I'm just printing it, and here you go, I got the print. So it says the squared values from 1 to 10 is 1, 4, 9, 16, 25, 36, 49, 64, 81. That makes sense, right? Now I also want to, I created this, computationally created values inside this container. This container has the boundaries: left square bracket, right square bracket. I'm going to use this word. Always recall this one. It's a kind of container. It's a kind of basket. Okay, within which we have computed quantities. And it doesn't mean that we have to only create this list, because I already said this. This is called a list. It doesn't have to be always computed. It can be created like this also. Look, I'm creating some string lists here. Berries, there are acai, goose, blue, strawberry, goldenberry, mulberry, goji berry, chokeberry, and then names are Ram, Sam, Pam, Mam, Dam, I am, Tam, and Bam. Okay, so all are uppercase. So why not? Let's keep that, because it might be helpful. I think. Let's do that. Okay. So I'm going to change some of them into lowercase, so it might help to see the ordering, when we do the sorting. Again, I'm just doing this, running this condition so that I can get multiple computed quantities can be printed, displayed. So that's why I need it, and I'm immediately using it here. So P, I call it for simplicity, the positive integer squared above here, I call them as P. So now I am, I'm saying it is a list, because list is, is something that has, left square bracket, right square bracket, and also it is also called mutable, not immutable, mutable. That means it can be changed, and we'll see how it can be changed. Okay, it can be added, subtracted, yeah, take away elements, put them, insert the elements, and so on. This you can do with another type of data structure called tuples. We'll come to that later. So I have this list, and two important characteristics of list is that it is the first is that, of course, this the left square bracket, right square bracket, and all the elements are arranged in a systematic way with a comma separation, and each of these position is called the index position, and that index specifically assigned to that particular item. In this case, 1 is assigned to this index, and the index always starts in Python with 0. Okay, so it's a 0 index position and its value is 1. 1 index position and its value is 4. Index 2 position has value 9. Index 3 position has 16. Index 4 position has 25. Index 5 position has 36. Index 6 position 49. Index 7 position 64. Index 8 position has 81. Remember these things. You're going to recall these things later. Okay. Index 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Yes. Okay. And then here, what are the index position? Again, 0, 1, 2, 3, 4, 5, 6, 7. Okay. And here also index 0, 1, 2, 3, 4, 5, 6, 7. So if I'm only going to call P7 is, what is the P7? 0, 1, 2, 3, 4, 5, 6, 7. It should print 64. That's what happened. What is P0? It is this one, right? 1. So that's what it's printing here. Let's run that one too. No, I just want to run this thing because I'm missing the order. Let's actually, how about we call the berries 4. Okay, that is 4, and that is golden. So let's go back there and see this one. 0, 1, 2, 3, 4. That's what golden is, correct? I can do that for names and so on. But the main point is, an interesting point is, given an index position, I get the values. That is straightforward. Is it possible to get, given a value, can we get the index? So sometimes that's useful, right? So here is that is what is called a method that is available for an object, list object. There's a method called index that will give you that. And the methods are always with the, comes with, the methods need to be applied with a dot function. Okay, dot. So p dot index means it's a method that is available for application with p, and that identifies p dot index. Index. I give the value. I want to find out the index position, right? So the value is 4, and you know that the value is 4 refers to here index as 1 because it starts with 0, right? So that's what is given here. So p dot index 36, I'm giving the value. What is its index? This is a 5 because it's a 0, 1, 2, 3, 4, 5. Okay. Likewise, you can figure out why p dot index 81 is 8, because you remember I told you that there are only start with 0, so it becomes here 8. Okay. All right. So we can also pick out values slicing the index. These are called slicing methods, and so I'm saying it's a range 3 to 5. And remember, the last one will not be included always. It starts with 3, 3, 4, 5, but 4 is not included. So only 2 values will be there. And if you print that, it becomes 16 and 25. This is what 16 and 25 is, right? 16, that is 3 and 4. 0, 1, 2, 3, 4. Okay. And the next one, we can also do more sophisticated slicing. So it says start from 1, go up to 10. It doesn't have 10 value, it doesn't have 9 value, but it says go. Okay, go up to 10, but skip every 3 values in between. Okay, so 1, if I skip 3, then I go to 4, and then if I go to further I skip, then I go to 7. Further I skip, I go to 10, but no, there is no 10, right? Index 10 is not there, so it's going to only give me the 1. That is 1, 4, and then 7. Is it correct? This is 1, this is 4. I'm sorry, 1, 2, 3, 4. Correct. 5, 6, 7. So that's why it is 4, 25, 64. Okay. I can do also this. We can do this range slicing, not just starting from. We can use minus numbers also, negative numbers also. What it says is, of course, you start from 1 to until what? All the way from the tail, one before the last one. That's what it says, one before the last one. So what does that mean? That means you will have 1 to it has only 8. Remember, it is not 9. It has indexes only 8, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. So it says all the way from 1 to 1 before, that is 64, but then you have to skip every second one. So we are going to start with 1, right? Index start with 1. Start with 1, and 1 means, for us, we know the value of 1 is 4. Remember that. Is that okay? I think it looks like confusing. No, it is 0. Remember, right? So 1 is 4. So that's why it is giving me 4. And then I'm skipping every second, right? I'm taking the every second one. So 16, 36, 64. That's the end of it, right? So you can look into very sophisticated slicing like this. Finally, if I just ask for p minus 2, that means 2 second point, skip 2 of them and then go to the next one. That is what we are going to pick up from the tail. So if I skip 2 of them, then I have to get, if I just go to the second one, that's what it simply says. Go to the second one, not skip 2. Skipping is different. Okay, this is goes the second one from the tail. That is why it is 64. So list has many methods. I want to quickly review the append, sort, insert, pop, remove, count. Okay. Append simply says add to the end. So you can you will see some example pretty soon. And sort simply says that you sort the list and provide the output to us. The sort method sorts the list and it modifies the original list. And then inserts a specific value, inserts a value at a specific index. Okay, at a specific index. And pop is the removes. If you don't give any index position, it will remove last entry. If you give an index position, specific indexed value will be removed. Okay, and it will rearrange the index also because of that, right? And in the same way, insert will insert something new at a specific index, and it will rearrange the because it will change the list. It will rearrange the index, and it will increase the size actually, right? And this will decrease the size. The other one is remove function. You can remove a specifically identified value. See, pop and insert works on the index base. Well, it is working using the index. Remove, remove works with the specified member value. And then dot count, tells you how many times a specific member value is repeated and so on. Okay, that's what it is. So let's just see these examples here. So I have the berries already defined. Again, I'm going to rerun this one because I kind of moved some, added some, and so on. And then I'm going to see, it says we want to slice all the way coming from fourth position, that is golden, and go up to the end. So that's what it is, right? Go up to the end. So it is golden, mulberry, goji, and choke. And then we are saying all the way start fourth position from the tail and go to the front, right? So again, we are talking about starting from the end. Remember, when the end positions, it starts, we don't include that part. So it start from this, it goes. So we define the range by saying that fourth position all the way from the start, all the way from the beginning until the fourth position, right? So that's why the golden is not included. Watch out for these little details. Okay. And then blueberry append, I can add append. I said dot append. I can add bill to this bilberry. There's something called bilberry, and then when I do that, you can see that bill is included here. Okay, and also I want to show as an example. Pop as an example. I pop this last item bill. Actually, I pop the bill last one. So let's run these things. Okay. So I popped that one. Now I am asking for BP. That is bilberries popped with the bill, right? Berries with the pop value. So that's why it is coming out to be. This one is popped with this is without the bill. And then what is that? What is the item popped is stored in BP, and the berries is now without the bill because I popped it. Okay, so first operation, first we do the pop, then whatever is remaining is here. Okay, so that's why this is without the bill. Now I told you that pop also works with a specific index. So what is the index? This is about, we are talking about the second position, right? We're not talking about slicing here. It's a second position from the left. So which we are talking about right now. I have only this one, choke. Okay, with up to choke, I'm not having bill also there. Okay? So watch out very carefully. So from the second, the choke onwards, right? That's what it says. Remember, this one is done. Yeah, we just ran this one, right? So what we are saying is, we did the pop, and then okay. So from this second, I'm sorry, second element is removed now. From this goji is removed. That's what I'm trying to tell. Okay, this is the last list we have, berries list, and from that we have removed the second one, which is goji. So I removed it, and then I'm kind of after I removed it, I'm printing. So you can see that there is no gojis here, and then I'm also actually printing what was that was popped, and that is goji. Okay, that was popped, and I'm printing it here. Let's sort the berries now. So whatever I have remaining, I'm going to sort it, right? So when I do that sort, because it doesn't have the Goji, remember that's where it is. So when I do that, it comes out to Akai blue change in the order. Goose, ventilator, choke comes earlier and so on. Blue choke, and so this is the ordered form, right? And then I'm also sorting the ordered names now. So so the uppercase comes first. That's what I want to tell you. Okay, uppercase, lowercase matters. Dam, I am, ma'am, bam, ram, rom, sam, bam, and tam. Because bam is again, because it's lowercase, it comes later. Now I want to tell you, because I already sorted that, I applied a function to it. It is replaced the names. But if you look at the sort function, if you want to do that, let's do that. It will not replace it. Okay, so I have done it. So I'm going to add B here. So I'm going to say, so I have to do the same thing, right? So let me go back and run names again, okay? Because I need the names again. I'm going to run this again. So if you do, I ran it because of that. Now if I ask for names, so here you have my original names in the order, right? Okay. Now I'm going to, oh, already it is there. I don't need to, uh, okay, I should have done it here. Then only I won't have the names here. If I ask for it, see, it is in the sorted order, okay? But after I ran that one, I'm getting the original unsorted order. I'm rerunning it, okay? Let's rerun it again. I'll go down here. I'll run it here. So I'm running this. Now if I ask for names, it is wrong. It is not sorted order. Okay, it is not. So names are as it is given. Okay. Now what I'm trying to say is, now I run this one. Let's keep a copy of that here. Uh, B, Control V. No, something happened. Oh, H should be H. I should say H. Mm. ESC H, it says, tells me that copy is really, here is an example in real life. Copy, yeah, copy is HC and then HV is paste. Okay, that's where I should say H. Okay, so this is names are already given. I ran this one. This is the original one, right? Ram, Sam, Pam, SPQR, Mam is there. So this is the original one. I'm asking for the names and it's the original one. Now I'm saying sorted names, and then I get that automatically. I don't even have to ask for it because it outputs it. Now I can store that if I want, right? Sorted names. I can store it, and then I can, if I don't store it, it will just print it. Now I have to call for the print. So if I say sorted names, then I get the sorted names. Now, what I'm saying is, if you go back to the names are still should be there as it is, right? Names. So if you look at this one, the order is, you see this one, the old order is still there. But if you go back to the approach that we have, that is sort methods. If I use sort method, it will replace, the new, the original list will be replaced with the sorted list. That's what I'm trying to say. Okay, so remember that if you don't mind keeping the sorted list in the original list, that is, kind of in place copy, then if you don't mind that, use dot sort. That is the method on the object, okay, list object. So with that, I want to stop here, give a break, and then I want to do the second part, doing computations inside the list. It's becoming bigger. Thank you very much. So.